Hello, Flat Earth researchers, debaters, and debunkers. Is this floor level or wonky and covered in dips and bulges and curves? Well, we know it's really an optical illusion. The floor is level, but the lines do an amazing job of really making it appear to have a curved, convex, and concave surface. You would naturally hesitate before walking on this, and it wouldn't be until you'd actually walked up and down the corridor a few times that you would feel comfortable just striding across what appears to be a curvy surface. And it's just because of the lines on there. This is another similar one where we have the appearance of a dip. It's just an optical illusion. It is a flat, level floor, and it only looks like it's dipping here because those tiles are they change shape, they become smaller, and they look closer together, more compact, and this gives us the illusion of curvature or convexity or concavity, if you like. So why am I talking about this? Because it's one of those optical illusions, and we can have the same misunderstanding about the surface when it's a level surface, but it is represented on a map by lines such as these grid lines here. This is just the kind of grid that you make polar coordinates from, so you can make an azimuth map, and this could be as familiar as maybe the North Pole, and you have one at the South Pole, wherever those points are designated. But essentially what we have here is just these lines which either converge or diverge depending on which way you're looking at them, because they are representing degrees. And basically all you have is a distance that compares to a number of degrees. I'm going to get into that later, but essentially what we have here is lines that appear to diverge and converge just like the lines on the floors that we saw just now. And even though this is on a flat surface, we can of course perceive it and imagine it as being on a curved surface, and or on a globe. And so we end up with what appears to be a spherical looking map on a flat surface, simply because of the lines. Now this might look a little bit different to what you normally see, because all I've done is move the azimuth point, the center point of our projection, to be over Africa. Now it still maintains its original azimuth as the North Pole and the South Pole down here, but you can see it's drawn everything together with these curvy lines based on where I've put the azimuth there. And so we get this illusion of curvature. But just as we saw with the floors just now, just because we have lines that converge or diverge to a particular point, it doesn't mean that the surface is actually curved. So that's why it's pointless to point at a map representing the same lines of longitude and latitude that are used for a globe projection as some kind of proof of the actual shape of the Earth. Regardless of what you assume came first, we've seen just now that you get this impression of curvature on a flat surface simply by putting wavy lines or converging or diverging lines on that surface. And all of a sudden we believe that the flat surface is actually curved. So the thing is, you look at reality. When you go and step on the floor and you test it out, you know it's not curving, and you know it's not moving. It's level, stationary, and flat, no matter what you draw on it, or how you represent it, or how it appears to be. Thank you very much.
Click subscribe and the bell icon if you'd like to receive notifications of new videos from Phuket Word.